In this video I'm going to show you how to integrate the Gaussian integral, which is the integral from minus infinity to infinity e to the minus x squared dx. Though it looks simple, there's a bit of a trick in how to do this. So we start by marking this integral with some letter, say I, and then squaring both sides. Now we can write the right hand side as the integral from minus infinity to infinity e to the minus x squared dx times the integral from minus infinity to infinity e to the minus y squared dy. Notice here that we can as well use y as the integration variable as x. If we open this up, we end up with the double integral, integrating both variables from minus infinity to infinity of e to the minus x squared e to the minus y squared dx dy. We can also write this as double integral from minus infinity to infinity e to the minus x squared plus y squared dx dy. Now the trick we're going to do is to change into polar coordinates. In polar coordinates, x squared plus y squared is just r squared, and we also need to change dx dy to r dr d theta. And to integration limits, instead of us going from minus infinity to infinity, coordinates x and y, we're going with r from 0 to infinity, and with theta from 0 to 2 pi. So we get integral from 0 to 2 pi, integral from 0 to infinity e to the minus r squared r dr d theta. Now notice that the derivative of e to the minus r squared is minus 2r e to the minus r squared. Now what we need to do is to get this minus 2 inserted here. We already have the r present. So what we're going to do, we're going to multiply this with 1 in the form minus 1/2 times minus 2. So we get minus 1/2 times minus 2r, so I'm just bringing this r front, times e to the minus r squared dr d theta. So what we're going to do is take this minus half out of the integration. And then we see that we just have the derivative of e to the minus r squared differentiated with respect to r. So the integration differentiation counter each other, and we end up just the integral from 0 to 2 pi minus 1/2 times that of e to the minus r squared evaluated at 0 infinity d theta. At infinity, e to the minus r squared gives 0, and at 0 gives 1. So we can write this as minus half times the integral from 0 to 2 pi 0 minus 1 d theta, or the integral from 0 to 2 pi times half of 1 d theta. There's no theta here, so we're just gonna get 1/2 times 2 pi minus 0, which is pi. Now remember that our original integral was squared here, so we still need to take the square root on both sides. We end up with pi equals the square root of pi. That's our final answer.